Section 5.5 is about inequalities in triangles. And we're actually going to start this section out with an example. So here's number 1. Draw an obtuse scalene triangle. Label the longest side and largest angle. Then label the shortest side and the smallest angle. What do you notice? First, we need to remember what an obtuse scalene triangle is. So remember, obtuse means it has an obtuse angle in it, and scalene means that none of the sides are equal. So I'm going to draw a triangle with an obtuse angle with no sides congruent. So here's my obtuse scalene triangle. I have the obtuse angle right here, and none of the sides are congruent, making it scalene. Remember, it says to label the longest side and the largest angle. So my longest side would be this side right here, and the largest angle would be the angle opposite the longest side. I'm also asked to label the shortest side and the smallest angle. The shortest side would be this side right here, and the smallest angle would be opposite the shortest side, so this angle right here. And now we're asked, what do you notice? As we said before, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. And if you think about it, this makes sense. If this angle is only opening up so much, it can only connect so far on the other side, as opposed to this angle that is opening up a great amount, so it needs to have a longer distance across from it to connect the other two sides. So again, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. Write this down, which brings us to our next slide. So our first theorem is 5.10. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side, just like we saw in the last slide. So if it's 8 on this side and 5 on this side, you can expect that angle C, which is across from the longer side, is going to be bigger than angle A, which is across from the shorter side. Theorem 5.11 says something as similar. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So once again, just like in the last slide, if we have angle 50 here and an angle of 30 there, the side opposite angle of 50 would be bigger than the side opposite the angle of 30. So BC would be greater than AB. And here is example number 2. 3 wooden beams will be nailed together to form a brace for a wall. The bottom edge of the brace is about 8 feet, and the sides are about 12 feet and 14 feet. One of the angles measures about 86 degrees, and the other measures about 35 degrees. What is the angle measure opposite the largest side of the brace? So let's draw a picture. So it says the bottom edge is 8 feet, and the two other sides are 14 and 12. So we have a 12 right here and a 14 right there. So 12 and 14. It says that we have angle measures of 86 and 35. We can find that third angle by doing 180, which is the total number of degrees in a triangle, minus the 2 angles that we were given, which is 59 degrees. So our 3 angles are 86, 35, and 59. So the smallest one is 35 degrees. You can expect that the angle that is opposite the smallest side would be the smallest angle. So the side that is smallest is the 8, so the angle across from it is going to be the smallest angle of 35. Our next biggest angle was the 59. Our next biggest side was the 12. So across from the 12 feet would be 59, which leaves us with 86 degrees in this corner, and it's the largest angle across from the largest side. So the question was, what is the angle measure opposite the largest side of the brace? So it would be 86 degrees since it was across from the 14 feet. And here's example number 3. List the sides of triangle RST in order from shortest to longest. So remember, the shortest side is going to be across from the smallest angle. So our smallest angle is 29 degrees, so the side opposite that is side ST. The next biggest angle was the 30 degrees, so the side opposite of that is segment RS. which leaves us with the side opposite the 121, which is RT. And that brings us to our last theorem of this section, Theorem 5.12, the triangle inequality theorem. It states the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Remember, sum means to add. So what basically it just means that AB plus BC would always be greater than AC. The same goes for AC plus AB would always be greater than BC. And finally, BC plus AC would always be greater than AB. We'll see an example in the next slide of that happening. And here's example number 4. A triangle has one side length of 11 and another of length 6. Describe the possible lengths of the third side. So at this point, we don't know if that third side is smaller than the 11 and the 6 or if it's bigger than the 11 and the 6. So we're going to have to account for both cases. Let's first look at the case if that third side is smaller than the 11 and the 6. But before we can do that, let's first let x equal that third side that we're not sure of. So again, first we're going to look at what if x is smaller than the 6 and the 11. And here's a picture to go along with that. So if 11 and 6 are the two bigger sides, the x would be the smaller side. And so according to the last theorem, we would know that the sum of any two sides is always going to be greater than the third side. So in this case, we're going to know that x plus 6 would always be greater than 11. So that would mean that x has to be greater than 5. So far we know that that third side has to be greater than 5. Now let's take into consideration if the third side is larger than the 6 and the 11. And so I've given you another picture. So if 6 and the 11 were the two smaller sides, x would be the biggest side. And we know that the two smaller sides added together would always be greater than that third side. So we would have 17 is greater than x, and so we normally would flip that around and say x is less than 17. So what that means is that that third side has to be greater than 5 and less than 17 at the same time. So if you are going to be greater than 5 and less than 17 at the same time, that means that third side has to be between 5 and 17. And again, that would be my final answer. The length of the third side must be between 5 and 17, according to the triangle inequality theorem that we saw on the previous slide. And that's it for this section. Make sure you jot down anything that you didn't understand so we can go over it in class before we move on, and we'll see you then.